Hello, STEM Nation. Jeff here, and welcome to episode number 63 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear, please share with a friend. Now let's get fired up today with our guest, Emily, and I hope our chat will help ignite your passion towards a STEM career. Emily earned a Bachelor of Science in Electrical Engineering from the Milwaukee School of Engineering and a Master's in Civil and Environmental Engineering from Stanford University, and is currently a Director in Optimization Engineering at 8-Minute Energy Renewables. Welcome to the show, Emily. Fill in any gaps and share a bit of your personal life.
Hey, Jeff. Thanks for having me. That was great. Just a few more things. I grew up in Amro, Wisconsin, a really small little town between Milwaukee and Green Bay. I got married in 2011, which was the same year I actually moved to California for grad school. I always initially planned to kind of move back to the Midwest, but boy, the weather is really nice out here. You can't complain. And me and my husband both have jobs and have spent the last 8 years out here. And now currently I live and work both in San Francisco at a solar development company.
All right. Thanks for that background, Emily. And let's dig right in here. So you've got a Bachelor of Science in Electrical Engineering, and then you went on for a Master's in Civil and Environmental Engineering. Can you go into why you made that transition from electrical into civil?
Yeah, well, it's kind of an interesting story. Is really I didn't know what I wanted to do exactly in high school. I knew I wanted to get into engineering at the time. I was good at math and science. So, through that, I actually had and went to an engineering camp that was, a 2-week long camp that I did in the summer. And at the time I was actually thinking I wanted to be a chemical engineer. So not either of those that I ended up doing is actually what I was pretty focused on at the time. And, this camp was really good. It actually helped me realize a couple of things about myself. One, that chemical engineering wasn't the right fit for me, was a lot more lab work and, kind of science experiments and a lot less practical than I wanted. And the second was it gave me an intro to this guy that actually completely designed his own house himself and was really focused on being 100% off the grid. So he actually designed his house to utilize natural light, solar, wind turbines, water turbines, a battery system, and was focused on his carbon footprint and, how he could help alleviate that through renewable sources. And, with that, I kind of really found my passion. I knew from there that I kind of really wanted to get into renewable energies, but just had to kind of find my own path there. He was an electrical engineer, which kind of got me pointed in that direction of like, well, maybe that's how you get there. I was really enjoying, the electrical pieces of my physics class at the time, circuits, electromechanics, that kind of stuff. I thought that was interesting and cool. And, at MSOE, I chose to start in electrical and did really well, liked classes I was looking at and what I was learning about, but it was still very broad. Electrical engineering as a degree, covers everything from electronics and robotics and, computer science to, power systems, which is where I started to kind of hone in that, and you can get kind of the utility in the grid and how the power systems and that part fits. And I also got a lot of exposure at the time through friends and my now husband, who was a mechanical engineer, to some of the other engineering disciplines. So he was in mechanical, and when I talked about renewables, he talked about his energy classes, so thermodynamics, heat transfer, fluids, and he talked about again, one professor that he had that was also just geeking out about renewables. Like this professor spent a lot of time to hone the coursework so that some of the examples touched in on wind energy and solar energy. And so I really got to talking to him and actually took on a whole bunch of extra coursework and to be able to take some of these applied, more renewable focused classes in the mechanical engineering degree. And so kind of started there. And when I went to grad school, I really wanted to take those broader degrees and kind of specialize. And although civil engineering and environmental engineering are broad, off the cuff, the program at Stanford, I was actually a subset, which was called Atmosphere and Energy Engineering. And, this whole program was really focused in on what kind of energy sources there were, conventional energy sources, so, natural gas, oil, coal, but also on renewables and how it all tied to air quality. And, this touched in from both the technical standpoint, the policy standpoint, was a really good program to kind of hone my interest when I knew I wanted to get into renewables.
So, Emily, you touched on something here a little bit I want to dig into a little bit is, in my mind, you go for a master's degree and you just, go electrical or civil and environmental, and you dig in a little bit, but you said that Stanford had a specific program. Is that typical of other universities as well, where you really want to look at the university and the master's program and what they specifically focus on?
Yeah, I mean, I think it's a matter of looking at some of the subset programs of the broader. So this atmosphere energy program fell under civil engineering. As an electrical engineer, I never thought I'd end up with a civil engineering degree. It was never really the path I was expecting to take. But looking at, the curriculum that went into that program and the research that was coming out of that specific grad program, it was really exciting and what I wanted to be involved with. So I think it's common for, a lot of master degree programs to have some specialties based on the professors they have there and the type of research they do, because, the courses that they teach are usually somewhat focused towards the type of research that is going on at that university. So I think it's a good idea to kind of take a dive deeper to kind of understand if there's a program of interest, even if it's in a broader kind of engineering program that maybe doesn't seem quite as natural of a fit.
So, Emily, how are you merging your electrical engineering background and your civil engineering degrees together?
Yeah, it's a great question. So, I actually ended up in renewable energies. So where I kind of have both and where I use both is that renewables kind of spans this kind of interesting group of electrical engineering and a lot of other disciplines of engineering, but also with civil more towards the environmental aspect of civil engineering. And so, I would say that the engineering skills and what I learned that I use kind of on the day-to-day of, the quote unquote engineering work that I'm doing is a lot more focused towards electrical. I got my PE in electrical engineering. So, I'm looking at plant design and cable losses and things like that in a solar plant. But also the civil engineering and specifically this program at Stanford taught me a lot more of kind of the other aspects that go into it. So I did learn in this program a lot of the kind of more detailed civil design aspects that play, kind of more some of the land things that like your land considerations and, your structural considerations, which, is not really my area of focus even now, but more around the renewables themselves, air quality. I'm not quite into anymore, but plays an important piece in renewables, especially around how the policy works and things like this. And so the environmental really, especially this program focused in to, renewables and tech and the industry as a whole. So I would say that, my electrical background is more, or my engineering background is more electrical, but the master's degree, which fell in civil environmental, gave me more of the holistic picture of how does renewables and how do the different engineering pieces fit into, both the technical and the policy and the actual kind of more entrepreneurship of any sort of field, and in this case, specifically renewables.
Okay, Emily, so we're going to get very specific here. And what exactly is your specific area of expertise?
Optimization engineering in renewable energies. So I work at a solar development company. So my focus is on solar technology, but also project optimization, which is it's kind of more, it's not optimization in the true sense of when you think of all the detailed math, but more optimization around thinking through and weighing the different trade-offs, both technical and commercial, and thinking through project design to really hone in kind of at the best LCOE or lowest cost of energy of building a solar plant.
All right. Thanks for that overview, Emily. And what is one thing that really has you fired up today?
Yeah, I mean, I think the thing that has me fired up most is that solar energy and renewables are really just getting started. We live in a world where people are starting to recognize that, we have an impact on the climate and, the air quality and things like this. And renewable energies are just critically important moving forward, thinking through how to really implement them in a grid and an infrastructure that, wasn't necessarily thought out of with renewable energies is like an exciting and interesting challenge. And you see California in specific kind of leading the way in some of these things. SB 100 just came out, which is basically the state's committing to 100% renewables by the year 2045. Other countries and, other states are doing similar things with their RPS goals. Other countries are in the Paris Agreement, which, helps kind of guarantee that they're aiming at cleaner sources of energy. And this is just a really exciting industry to be in at the time, from just the PV side, but also as we, move into other technologies such as PV plus storage, which really is going to help renewables kind of hit the next level of how do we work with the grid? How do renewables, which are, intermittent, they are there when the sun is shining or the wind is blowing, but, storage is going to really ramp them up to the next level of how do we use renewables in a way that is not only, good for the environment, but practical. And that's important to me and exciting to be a part of.
All right. Thanks for that, Emily. And you use the term PV, which is, for those of you that don't know, that's photovoltaic, which is essentially think of as a, solar energy. Emily, everybody loves a story. Could you tell us a story of how you turned an aha moment into success?
One of my biggest aha moments was early in my career. I worked at a different solar development company at the time, and I was actually on the phone with a counterparty that was looking to potentially, invest in one of our projects. And this was a relatively technical call. We were talking through some of the ins and outs of one of the tests that we were going to do during our commissioning process. And I had all of the engineers on their side of the phone agreeing with the approach, that it was technically sound and reasonable. And, they were completely on board with how this worked. And the commercial people on the phone and the deal people on the phone on their side of the table said, well, that's great. I'm glad the technical is sound and, the testing you're doing is, industry standard. And, we're happy to hear that, but we just don't care. Like they didn't say it quite so bluntly, maybe, but more to the extent of like, even though this is true and the technical and our team believes the technical is sound, there's still risk that we see around, certain aspects of the way this test is run. And there's certain things that matter to us a lot that, currently aren't a part of this test. And, the takeaway from there was, I then had to work tirelessly to kind of rewrite our procedure in a way that, actually turned out to be less technically sound, but covered the aspects that they were more concerned about. Certain things that they were really, they had seen potentially go wrong in the past, or they just were really details that they wanted to make sure got considered. And so, from that was, very early in my career. And from that, I took away kind of two big things. Is one, that there really is no quote unquote right answer to any of the engineering problems that you solve in the real world. There's a lot of answers, and some are better in some ways than others. Some may be technically better, some may be monetarily better, some may be more practical, some may cover risk. So really learning to not think about technical in a bubble really has been a big deal in my career, thinking about how all those parts and pieces play together and realizing that there's trade-offs. Usually the best technical answer is probably not the cheapest to build, and finding that balance between those trade-offs has been important. The other piece that it kind of made me understand is related is that it's a really interesting place to be when you are kind of the bridge between technical and commercial. You're basically kind of have to be able to speak two languages in a sense. You have to be able to translate technical importance and risk and things into a world that speaks in dollars and, contracts. And so being able to understand both pieces and being able to communicate is not a very common skill set, but it's a really powerful one as an engineer because you will know the technical side more than some other people in your group, and cross-functional you need to be the representation of the technical side and help them understand the parts and pieces that are deal breakers from the technical, and you have to apply that in a very commercial way.
Yeah, absolutely, Emily. And to whittle that down to one summary, I would say that engineering always meets business, and the two have to work together. It might not be the best engineering solution, but it might be the best business solution. So, STEM Nation, keep that in mind and listen to what Emily is saying there. And Emily, we're going to transition back to when you're 18, heading off to college. What's some advice that you would give your 18-year-old self as you're heading off to college so you could launch successfully?
Yeah, I mean, I think one of my biggest pieces of advice is to talk to people, your teachers, your classmates. Basically, you want to kind of understand and learn from the people that have either already went through this or maybe have different experiences, exposure than you do. One of my best examples of this is in high school. I knew I was and really enjoyed math and science, but I didn't really know what to do with it. I was thinking about accounting because I was talking to my aunt who was an accountant, and that seemed like an interesting career path. I had a professor or a teacher, I guess, at the time. My math teacher actually really encouraged and helped me kind of navigate the path. His daughter went into engineering as well, and he helped really push and navigate of, you should consider engineering, and here's some of the great schools, and here's some coursework that might be valuable. So talking to people about your interest, learning from the people around you is really an important piece. The only other piece that I would say that I would kind of harp on as you go in is that, the material you're learning college is important. I'm not going to downplay that it's important that you learn the technical aspects and the math behind it and how these things were developed. But really, the bigger picture of it is what you are learning, and maybe you don't realize then, is a thought process. Is how do you solve complex problems? How do you think through when you don't have all the details? And more than anything else, I mean, it's been great in the real world now to remember some of the math formulas, or some of the detailed electrical engineering calculations. But realistically, a lot of those details I don't remember off the top of my head, but I can look back into a textbook or look online, and I know how to think through the problem. I know what questions I want to answer, and I can pick up on, stuff that I both learned and stuff that, maybe you didn't learn explicitly, but you have the right kind of formula, the right kind of thought process to think through it and get to an answer.
All right, Emily, and we are going to head off into the lightning round. Are you ready?
Let's do it.
What's the best piece of advice you've ever received?
I think the best piece of advice that I've ever received is be bold. Engineering and renewables in specific, I mean, the engineering's been around for a long time, but it's still a growing field. I mean, it was not uncommon for me to be the only girl in my class, or when I started in my career, to be the youngest person at the table where, a very big decision is being made. And so being bold and realizing that you have something to contribute, and really speaking up to, ask questions and learn from that process when you're new and don't understand is a big part of that. But also to help build the confidence that, in a lot of ways, you do know what you're talking about. You are a subject matter expert in the piece that you have learned, and, using your background to help other people understand how that piece might play in other aspects is just something that you have to kind of learn to speak up, and, doing that in a way that is concise and clear, but really just learning to kind of trust yourself and really kind of be bold and speak up.
And a personal habit that contributes to your success.
Something that's contributed to my success greatly is to find outlets, to find ways to kind of shut off and balance. This was true throughout, school, but also in the engineering field. Is there's a lot of work that goes into an engineering degree and into an engineering career. And so finding ways and things that you enjoy outside of just the school aspect. I mean, you hope that and you try and find the things that are interesting within your career, but finding ways to shut off is important.
All right, Emily, and as we wrap up here, could you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
One of the parting pieces of advice that I would share is to really kind of find your own path. It may not be the straightest one there, but by taking opportunities that, maybe you're not exactly sure where they lead, but there's something you're interested in, it really helps mold and define your path, that you can kind of hone in on what you really enjoy about either certain topics or what you're really interested in. And I would say that every step that I've taken that's been maybe non-traditional or even sometimes inconvenient in timing, because I was interested in it, has led me to other doors of things that I was interested in and wanted to be a part of. And so really finding your own path is important, I think.
All right. And with that, Emily, we will say goodbye.
Yeah, thanks, Jeff. It's been great talking with you. And bye, STEMers. Good luck.
I hope you enjoyed that chat today with Emily. You can head over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player and share it with a friend. Tune in next week to talk with Aaron, who is an applications engineer. Until next time, I hope this chat has helped ignite your passion